Hello, welcome back to the channel. In this video, we are going to look at the difference between the four types of functions that we are concerned about in grade 12. So we have linear, we have parabolic, which are also known as quadratic functions. We have hyperbolic, or hyperbolas. We have exponential, which are also known as geometric functions. And there's a difference in the four types of functions, mainly the formulas. That's what differentiates the four functions. So with linear, we can have, sorry for that, we can either have this or that. Basically, as you can see, these formulas are just the same formula. It's just the use of different variables. Either the Q or the C to represent what is called the y-intercept. We can have A or M to represent the gradient or the steepness or the slope of the function. So if that A is positive or the gradient rather is positive, that means our function is going to be slanted to the right like that. If it's negative, our gradient is going to be slanted, our line rather, our function is going to be slanted to the left, just like that. And we have parabolas or quadratic functions rather, which can be given by either one of these three equations. So the first one, I think, is the most famous one that most of us we are familiar with. And whenever the A in that equation is positive, that means our graph is facing up. Is it concave up? I think that's what some refer to as concave. And the one where the A is negative refer to it as convex. That's just facing down. Smiling or being sad. Some teachers usually put it like that. When the A is positive, you are smiling on a positive day, and on a negative day, you are just sad. So it's gonna face down. I think that's just one of the ways in which you can go about remembering the shapes. And also before that, let me try to differentiate between the three types of equations. It depends on the situation which one makes it which one to use actually, because sometimes it's easier to use equation 1, sometimes it's easier to use equation 2 or 3. So with equation 1, it's just a matter of maybe if they might give it to you in that format, or you might just have to rewrite it back into the format depending on the question. But with that equation 1, I think that's the most general one. Usually we'll try to use that one, but in the case whereby the x-intercepts are already given to you, it's better to just use the second one, since x1 and x2 they are the x-intercepts. And if maybe you are interested in the turning point, the third one is also easier to use. But either way, it will depend on the situation. You might just use one of the three. It's not really a complicated situation, because the three equations, they are basically the same things, just written in different formats. So you can complete the square from equation 1, which is this one, and then get to equation 3. Or you can factorize equation 1 and get to equation 2. So, and whenever you multiply out both equation 2 and 3, you can go back to equation 1 in that format. So there isn't much of a difference or not much to worry about. We'll do examples with each of the equations, and then you'll be able to see how we apply them. At this point, relax. So we have a hyperbola. The equation is given by this. Sometimes they put a plus here. Plus just basically means you move the original function to the left. Okay. Minus means you move the original function to the right. And also this plus q, it basically just moves the original function upwards. If it is negative q, that means the original function, you move it downwards. That's basically the situation. So you also need to remember these shapes, because whenever you draw a hyperbolic function or a hyperbolic graph, you need to indicate these two pieces. So this piece and that piece. Sometimes when A is negative, you need to indicate this piece and that other piece. So it will depend on whether or not the A is positive. You draw these pieces in pairs, basically. So you need to know which quadrants to put them in, depending on the sign of the value of A on the function. Okay. Examples, we're gonna do them later. For now, it's just me trying to summarize the situation. So we relax, we are together. And then we can have exponential functions. Exponential functions, okay, maybe that's where you have quite a number of shapes to remember, but it's not that complicated to remember them nonetheless. So this is the equation, as you can see. So plus q basically means you're moving, or it's basically that means that q, it's in this case q is not what? Q is not an asymptote value. It's instead, yeah, it is actually an asymptote value. Let me not lie to you. Q is actually an asymptote value, the horizontal asymptote value, as it is the case in hyperbolas. It is horizontal asymptote value. So to determine the shapes, we use only A and B. So when A is positive, the graph is always going to be above the horizontal asymptote. When A is negative, the graph is always going to be below the horizontal asymptote. So how I usually try to remember these shapes, these four of them for exponentials, is to treat B as our M. Because if you have been doing this mathematics for quite some time, surely now you already know that when M is positive, means it's greater than 0, the graph is going to look like this. So I treat B as M and 1 as 0. So you see, with B being greater than 0, I will then know that this is going to be the shape. It's just my way of memorizing the shapes, basically. You can either take it, but if you have your own way, it's fine. So this is basically the situation for both, is for A being greater than 0. So when A is greater than 0, I'll treat B as M and 1 as 0, and I will get to know that the shape of a straight line is going to be like this. So now I just draw, what do you call this line? I mean the shape of my graph that I'm interested in, which is the exponential graph. And then what is happening when B is less than, when M is less than 0, I know that the line is going to look like this. That's for negative gradient. And then that means B is also between 1 and 0. Okay, it's less than 1 but greater than 0, like that. So the shape of the exponential graph is going to be something of this nature. I hope you get the picture. This is just my way of memorizing it. I don't really have a scientific way of explaining it, but it's just a way of being able to make sure that I don't get the shapes wrong. And then for the very same conditions about B, if they are now saying that A is no longer greater than 0 but it's less than 0, for B being greater than 1, and I'm just going to take that very same graph, this one. If you remember, this very same graph, I'm just going to flip it like this. Okay, then I'm going to put that shape here. And then for B being between 0 and 1, I'm just going to take the very same graph that I had, this one, and I'm going to flip it. It's going to look like this when I flip it. Yeah, I'm just flipping it about the horizontal asymptote. So that's going to be my shape. So I'm going to put this shape here, as you can see. So yeah, this is pretty much how you can go about memorizing the shapes for exponential or geometric functions. And let's look at some of these things in the parameters for each of these functions. We spoke about A and M being the gradient, and C is as well as the Q for the linear function. Those are the y-intercepts, and what else? There's nothing much about that. And then we go to quadratics or parabolas. You know that we have the C there, which is the y-intercept, and we have P and Q. P and Q, those are the coordinates of the turning point. So you just need to change their signs. Sometimes, like I said, if I did, they write plus P there. So to get the turning point coordinates, you're going to put minus P and Q. If they wrote plus P, you just change the sign of that P. But if they write minus P, you say P and Q, those are your coordinates of the turning point. Okay, sometimes you can use this formula to calculate the axis of symmetry as well as the coordinate or the x-coordinate of the turning point. So as you can see, they are equal. And what else? X1 and X2, those are your, what you call the x-axis. Oh, not the x-axis, the x-intercepts. So those are the x-intercepts. So as you can see, where is it demonstrated? Here, those are the x-intercepts. And Q could be the y value of the turning point. Q could be the y value of the turning point. But I hope the fact that I wrote it as coordinates here, you can tell that this is the y value of the turning point. Okay, and what else? I just want to see if I've covered everything. The domain acts as an element of real numbers. Did I speak about domain and range earlier? Actually, I didn't. In the previous video, I was supposed to talk about domain and range. Domain and range, I'm just going to squeeze it in here. So domain and range, when they speak about domain, they're just talking about all the possible x values for the graph, and then the range is all the possible y values for the graph. So to remember which one is for x, which one is for y between domain and range, just remember that between D and R, D comes first alphabetically, and between x and y, x comes first alphabetically, y after. So you can see D domain for x values, range for y values. That's basically how you can remember those. However, don't worry too much about getting the domain and the range. We'll do a couple of examples. You'll be fine with that. I hope after doing a couple of examples where you are required to get the domain and the range. For now, let's just focus here. And what else do we need to know about those different formulas? We know about them. So we can have a situation whereby you are required to find the equation of a graph. So when you're required to find the equation of the graph, you can use different approaches depending on what you are given. So sometimes, especially for the linear, it's always easier to even use that equation that we were using when we were doing analytical geometry. So you can just use this sometimes when you're given a point on the line, as well as maybe you have a way of finding the gradient or the gradient is given. You can just use this and then you'll be fine. Remember that m is the change in y over change in x as demonstrated here. And sometimes they tell you about lines being parallel or perpendicular to each other, or maybe you're given the angle of inclination of that line. You can just use these different steps like here, if you remember the whole politics. But nonetheless, these are just the things that you can use. If you pretty much aren't that familiar with them at this point, we'll do a couple of examples, then you'll be fine. And what else do we need to know about? For x, the linear graph, x is an element of real numbers, that's the domain, and y is an element of real numbers, that is the range. Because usually when you draw a linear graph, you draw it like this, and you just show that it goes to infinity in either direction, up or down, on either side, left or right as well. So yeah, we have parabolic or quadratic functions can be given by that or this one. So when we are trying to find the equation, we'll use this one when we are given the turning point. We can use this one when we are given when we are not given the turning point, but we probably know the x-intercepts. So we can use the second. This is the equation number 3 on this list, if you remember. So yeah, we'll do a couple of examples. That's the range, the domain as well as the range. But don't worry much about domain and range. We'll do examples like I said. And we can go to hyperbolas. The P and Q, they just give you the coordinates of the asymptotes, and we can have a way of getting the increasing or decreasing function, which are the axes of symmetry. Remember, I gave you these two equations. I left the others, these ones, because to me, I think they are just longer unnecessarily, but you can take them if you feel like it. It's fine. And we have what? steps of drawing graphs. If you can see, for drawing the graphs, either linear, quadratic, exponential, or hyperbola, we always need to find the intercepts, x and the y intercepts, and after that find the asymptotes. Immediately you plot the intercepts, you plot the asymptotes, you already see where you're going in this whole situation. We'll do plotting in the next video. Continuing with hyperbolas, this is the only equation pretty much that you usually have. So when you are required to find the equation, just know that you need to rewrite the main equation that you are going to go to. You are targeting, and then try to find the unknowns on that equation. You'll have different ways depending on the different information that could be given to you. And for exponentials, the equation will be given to you. Relax, it's often given to you, so you don't have to try to get it. Other than that, I think we see each other in the next video. That's pretty much the difference in these the 4 types of functions. There isn't much to worry about. We'll do a couple of examples, then you can be confident in functions. Remember, they carry a lot of marks in paper 1.